Hello everyone, in this video we are trying to learn the process of extracting raster values in the Earth engine. The objective is to make ourselves aware about the codes and the process in Earth engine. The contents are adapted from the Earth engine tutorials. Raster values are important for any remote sensing projects. For this, polygon files are created, or the center point with certain radius are generated for the process. Plots are not usually directed at the center of the pixels. There are certain positioning errors. For raster values, average values of the adjacent pixels are calculated. Buffer, in the other hand, are influenced by spatial resolution of the dataset, the size of our field plot, and the error from the GPS. Let's try to understand the codes. There are two functions in this code. The first function is to set the radius and bounds. Radius is in meter and bounds specifies if the rectangle or the four sides will be the bounding shape. The function lets us know more about the process here, this function here. So if we have the dot bounds, this creates the four-sided buffer, and this question mark here lets us choose the condition. If something is true, it chooses the first one, and if something is false, it chooses the last one. So here we can run this for the demonstration. So here is this function, and here the number has been provided, and I have set it as false. So this generates 8, so only the addition has taken place. And if this is true, then the number is different. The first one is chosen for the process. And the second one, and the second thing to know here is if we have the bounds, dot bounds, this creates a four-sided polygon or four-sided buffer. However, if we remove this one, this creates the circular buffer. And these two concepts, or these two things, has been uniquely used to create the very first function. So here the radius is given, and the user is set to choose true or false. Based on that, if it is true, the buffer is rectangular or four-sided, and if it is false, then the circular buffer will be created. And for this we provide the points. This is being done in the points. So this is the first function. And then we have the second function, a long one and complex one, in this sense that many things are going here. So I'll try to explain as much as I can. The very important one here is that three different things. The image collection, this is represented by IC, FC, these are the points or the feature collection, and finally some parameters that we provide. In the last section, we see reduce regions here. We have the collection. This is our collection, and we have the points bounded by the filter bounds here above that, and we have the reducer, we have the scale, and we have the CRS. and we are also adding the metadata to each feature. So let's remember this for now, and let's begin from the top. So at the very top we have the params with underscore params, the new variable, and here we have set the default values, and here we have the min reducer and scale, CRS, bands. These other parameters are set as null. And the second one here, we replace the default value or the default parameter with the user fitted parameters. We are replacing the default ones with the new one. And the third one here, we are trying to get the first image, and we retrieve different values. So we see the band names being selected and being provided to this one, and then the bands to the bands to name, and also we see that there is a if condition at the very beginning, and then we have this exclamation mark. This makes the condition false. For example, if there is this variable exists, then it will be turned as false, and forces the variable to update itself. So this is the process here. This is just the selection of those parameters from the very first image. So the band names are given to the underscore params.bands, and the bands name, and also the image properties image properties name. So these things are being done to set our selection from the first image. Then we have the function here, reduce region function. So this will be the main function here. So here we select the bands and provide the date and time property. Date and time properties. Here the two lists are created where the properties are being changed from one property to the other. So this is the main important one here. We are renaming from this to this one, and before that we are creating a list just from the above. Then we select the points. So we had started to understand this from the beginning. So we are creating the filter bounds, or the points being in our image, and then we reduce the image by regions, and we provide the metadata or other information to each feature, and then we return the results. So from my understanding, things here are working to change the variable names. So everything depends if the initial values are null or not. So user might not input all these variables. So based on these inputs, the renaming will occur. So that is the main thing to understand. But inside each of these functions, so many things, or so many learning resources, or let's say learning tips are inside this. I would say that. But there is more explanation in the tutorial page itself. So after the creation of these two different functions, now we are towards the raster value extraction. So here we have different points, 5 different points, and these are created as feature, and then finally all the features are being convert it into the feature collection. So this is the way to create the feature collection. Or we can also export the, we can also import the this point files into the Earth Engine, or we can upload them as well. So here we can see the very first function being applied. So we have this buffer points. 45 means this will be have the 45 meter radius, or 45 meter to that specific buffer, and then we're setting this as false. So this will create the circular buffer. So here we have the first application of those two functions for the DEM, and let's see this one here. So it starts with a selection of our data set. We are calculating the slope, and we are concatenating or grouping those two different variables as the band. So this dot cat here works to create the two bands for that image, and we also preserve the time properties, and we create the image collection from that grouped images. And then we also have some params. We have bands 0 to 1. We rename the bands here. So we provide these params to that second function in this way. So we have the image collection, our feature collection, and our parameters, and we can print them out. Finally, for the Modis, this is the second case here. And for this Modis, we have the points again with 50 meter radius, or the units for the buffer, and it is set as true, meaning we will have the four-sided buffer, and then we provide the params. This will be used in that second function. We have the Modis dataset here, and we have depth filters, and we were specifically filtering the specific parts of the year, and then we provide those variables to that function, and we can print the first 50 values. Similarly for Landsat, here we have the for the Landsat, and for Landsat, the first one is the creation of that cloud masking function. Then we have the renaming function. We are selecting the bands from band 2 to 7 and renaming it. Then we have the second renaming function, and then we integrate both of those two functions, renaming functions, and then we also have the same thing repeated for the other one. So basically what we're doing here is we are trying to harmonize different Landsat sensors. So you can see different Landsats here, 8, 7 and 5, they are merged, and before this the functions written above were to rename the bands and masking the clouds. And there is also a helpful tutorial in the Earth Engine tutorials just for the harmonization of the different Landsat sensors. So that is also the interesting one to learn. And after merging these different Landsats, we have some params here provided to the second function, and finally we can print them. And we can export those as CSVs or into the asset. So this can be done by export.table to asset, export.table to drive. So this much in this video. So there are so many things to learn from this course. Basically the second part, or the second function, has so many things that we can utilize in our own functions. So I hope this was helpful for you. So thank you for watching.